Hey everyone, have you ever wanted to make your very own video game but didn't know how? If the answer to that question is yes, then you've come to the right place, because in this tutorial series I'm going to teach you how to make your very own video game using Godot. Now, for those of you who don't know what Godot is a open source, completely free game engine. A game engine is essentially a framework for creating games which provides common tools so you can make your very own video game without reinventing the wheel. Some common engines that you've probably heard of include Unity and Unreal Engine. But in this series I'm going to be using Godot as, first off, it's more beginner friendly. It's also open source and completely free. There's no strings, no royalties, or anything. Because in Unity, after you earn a certain amount of money, then you have to pay a cut to Unity. In Godot, there's nothing like that. Godot also supports multiple programming languages, including but not limited to C#, C++, a custom Python-like language called GDScript, which we're going to be using in this series, and a visual scripting language called VisualScript. It supports both 2D games and 3D games. And so in this series we're going to be making a 2D game in GDScript. In this game we're going to be controlling a player which has to move around collecting coins while avoiding enemies. It's a simple game, but it's a perfect introduction to Godot and game development. So to start off, go to godotengine.org, the link will be in the description below, and click the download button. The current version for me right now is 3.1, yours might be different. Okay, wait for it, and then it'll take you to the download page. Choose the correct version for your operating system, and then download the standard version. Now, I have a 64-bit computer, so I download this one. I already have it, though. So then you open it. I have it on my taskbar, and open up your project manager. Now, it'll also open up the terminal, but you don't need to worry about that. So this is called the project manager. This shows all of your Godot projects. Yours will be empty as you don't have any projects yet. Now what I'm going to do is, you can either go to templates and choose one of the templates that come with Godot, so you can try it out, or what we're going to be doing is we're just going to be making a new project by clicking the new project button. So first give it a name. I'm going to call it tutorial 2D. Okay, and then choose a project path. The project path is where this folder will be stored. Click create folder, and then leave the render the same. Click create and edit. Okay, and then it'll open up Godot, and that warning popped up because I'm using the mono version. Okay, so before I continue, I just want to take you on a quick tour of the user interface. This part in the center over here is called the viewport, and this is the scene of the game. Basically, this is where all of the in-game objects will be, like your player and your enemy and your coins. These are known as nodes. On the top left over here is a scene tree. This scene tree will show all the nodes in our scene. Right now we don't have any nodes, so it's prompting us to make one. Just leave it as it is for now. Right under the scene tree we have the file system. This will show all of the files in our game. So every file in Godot is stored inside of this res folder, and then Godot gives us this .txt resource file, default environment, and a PNG image called icon, which is just a Godot icon. These tabs on the bottom allow you to view the output console, the debugger, the audio editor, and the animation editor. This on the right is known as the inspector. This allows you to edit a node's properties. The node tab next to the inspector, you can use this to edit signals and groups. We'll learn more about this later. And then there's the import tab here, which we'll also learn about later. The tabs on the top allow you to switch between 2D view, 3D view, the script editor, and the asset library. So go to 2D view, and then zoom out using the mouse wheel. And you can hold down the mouse wheel and look around like this. So this blue box over here is what the camera will see. This is a viewport. So when we run the game, anything that's inside of this viewport will be seen by the camera. So whatever we make, we want to put it inside of this viewport. So let's create our first scene. So on the scene tree, click new 2D scene over here. And then we have a node 2D in our scene. Double click the node 2D to rename it. Call it world. And click enter to confirm the rename. Now, we're going to be adding a player to our world. Okay? So click Control A to add a new child node. You can also click the plus button or right click and click add child node. So I'm just going to click Control A, Command A on Mac. I'm going to add a kinematic body 2D. Now a kinematic body 2D is a special type of node which is usually used for controlling, it's meant to be controlled by the player. So this is what we're going to be using as our player character. So double click it to rename it and call it player. Now we can actually see it. So to do that, add a child node to the player by clicking Control A again, and this time choose a sprite. A sprite is just a node that can display an image. So you can drag icon.png over to the texture property in the inspector over here. Oops. Okay, there you go. Now as you can see, we can see our player now. Okay, so now it's kind of in the top left of the scene, and we don't want that. We want it somewhere in the center. So how about if we just try dragging it? Now that seems to have worked, but if we click on the player again, the player is still here. It just moved the sprite. So click Ctrl Z to undo, and with the player selected, click this button over here. This will lock all the object's children to the parent. So now we won't be able to select the sprite, only the player. We can move it down. But if we look at its position now, it's a decimal number, 509.845 instead of 509 or 5010. Now, it's easier to work with whole numbers and not decimal numbers. So I'm going to undo, Control Z. Okay? And then I'm going to click this button over here. It looks like a magnet with 3 dots. This will turn on grid snapping. And it will snap it to a grid. Now, it's a whole number now, as you can see, but we can't actually see the grid. So if you want to see the grid, you can go View, Show Grid, or you could just use a hotkey G. There's our grid, but it's kind of tiny. We don't need it this small. So you can click the 3 dots next to the grid snap option and click Configure Snap. And now change the grid step from 10 by 10 pixels to 64 by 64 pixels. Like that. Okay, now if we try moving the player around, as you can see, it snaps to this grid, which is good. So I'm just going to try to centralize it somewhere here. Okay, I think that's good. Now let's save our scene. So click Control S to save, Command S on Mac. You can also go to Scene and Save Scene. And then I'm going to save this as world.tscn. Click Save. Okay, that works. Great. So now we're going to run the scene. So click the Run Scene button on the top, or you can click F6. There you go. Here's our scene. So now we have the player in our scene, but the problem is it doesn't do anything. It just sits there. What I want to do now is if I click the right arrow key, I want to move right. If I click left, I want to move left. If I click up, I want to move up. If I click down, I want to move down. So now, if you want to add logic to your game, in this case, reacting to player input, you need to attach a script. So to do that, close the window. And with the player selected, click the Add Script button over here. It looks like a scroll with a plus button on it. Click that. And it'll say Attach Node Script. Now keep the language at GD script. And you can leave all the options the same. Just click Create. And it'll open inside of Godot Script Editor. Just close the Output tab. And now, what does all of this mean? Okay, let's go line by line. The first line says extends kinematic body 2D. If you remember, the player is a kinematic body 2D. Okay, that line makes sense. But what does that extends word mean? Extends, what this does is every file in Godot is a class. A class is basically, you could think of it as an object. Okay, so every object, or node in this case, has properties and methods, which are basically values and functions. So now what this extends word allows us to do is take all of the properties in Kinematic Body 2D and add more functionality to it. Okay, so these lines over here that start with a hashtag, these are just comments. Okay, this is a comment, right? And comments are ignored by the computer. Okay, so Godot will not run these lines. These lines will be ignored. This is just for people, so we understand what each line does. Okay, so we'll just delete these comments for now. We don't need them. Delete that. Okay. Now, this next line over here says, oops. This line here says func_ready. And what that means is this func keyword defines a function. A function is basically a block of code, and the _ready function, as you can see, the comment says, called when the node enters the scene tree for the first time. Okay, so when this node enters the scene, it'll call ready. This pass keyword means that we're not sure what we want to put in the function yet. Any indented lines after the colon are part of the function. Now we can just delete all of the comments. We don't need them. And actually, you can just delete all of this except the extends Kinematic Body 2D. Now we want to add motion. So to do that, what we want to do is, first let's create a vector. Now if you don't know what vector is, or you don't fully understand vectors, then I will link Godot's page on vector math in the description below. So I'm going to create a new variable. A variable is just a way to store data, and you can declare it using the var keyword, followed by its name, which in this case I'll call it velocity. Oops, velocity, like that. Followed by equal sign and its value. So var velocity equals, I'll set it to a vector 2, a two-dimensional vector. Open bracket, closing bracket. Okay? Now once I've got that, I want to constantly check if the player is clicking anything. So if I want some code to run constantly, I'll have to put it in physics process. Physics process runs 60 times a second, okay? I'm just going to write pass here because I'm not sure what I want to put it in yet. As you can see, I had autocomplete. Now, if you don't have autocomplete, go to editor settings, editor settings, and then type in hint. And then under text editor completion, make sure type hints is on and not off. If it's on, then you should have auto completion. So before I add any logic to check if the player is clicking anything, what I want to do is, if the player is not clicking anything, I want to reset the velocity. Velocity equals vector 2, like this. Okay, so the player is not clicking anything, and resets the velocity so the player doesn't move at all. Okay. Now we want to check if the player is clicking something. So to do that, we're going to need to use a conditional statement. So we write if followed by a condition, a colon, and then any indented lines after the colon are part of the if statement. So this, let me just put this code will run if condition is true. Okay? So what condition do we need? If, well, we want to check if a key is being pressed. So if input dot is underscore action underscore pressed, make sure you do pressed and not just pressed. If action pressed, and then choose UI underscore right. So if we're clicking the right arrow key, close bracket, add a colon, increase velocities x by 1. This plus equals means increase by. So it'll get the current value of velocity.x and add 1 to it. So now let's see if that works. I'm gonna click F6 or the run scene button. And now if I click the right arrow key, I'm holding it down, I'm clicking it, nothing's happening. Now the reason for this is we're just storing a vector inside of a variable. We're not actually doing anything with the vector. So how do we do this? Well, I'm going to look at the docs for the kinematic body 2D. You can do that by control clicking. And if I go down, you'll see that it has a function here called, if I could find it, where is it? Here it is, move and slide. So it moves the body along a vector. That's exactly what we want. So let's call that over here. Make sure this is not indented. Okay, right, move underscore and slide. There it is. And it expects a vector 2. We have a vector 2 called velocity. We'll pass that in. Close the bracket. And if I run the scene now, remember F6, and I hold down the right arrow key, the player very slowly moves to the right. The webcam's inverted, so I guess that's the right. Okay, so it moves to the right. Now, it's very slow. So what I want to do is, before I move and slide by the velocity, I want to multiply it by, this means multiply it by, over here, times equals. I want to multiply the current value by, let's say, 100. Okay, so now if I run the scene, F6, as you can see, when I hold down the right arrow key, it moves right. When I let go, it doesn't move at all. It's exactly what I wanted. Now, I'm actually going to store this as a variable, this 100 here. So, over here, right under this var velocity line, I'm going to write export var speed equals 100. Now, what does this export keyword mean? Now, if I select the player in the scene tree, in the inspector you can see script variables, speed. What this does is, what the export keyword means is, it exports this variable into the inspector. And then we can edit this here, instead of having to change the code just to test it. And I like exporting my variables, so you can export that one too. I can create another variable, like say name, set it to Bob or something. Export that as well. Oops, export var name. Player name. Change that there. So all the export keyword does is it puts a variable in the inspector. So now I'm going to multiply this by the speed and run the game, and you should see no difference. Okay. So this code and the code that we did before is the exact same thing, but now if during runtime, if I think this is moving a bit too fast or a bit too slow, I can edit this. Maybe I think it's moving a bit too fast. I want the player to move slowly. I can change the value to like 25. Now, player will move 25 pixels. If I change it to 1000, or not 100, 1000, that, now, it's moving much faster. I can click that reset button to reset it. Okay, I'm just going to close the window now. And now I'm going to add movement in the other directions. Left, up, and down. So now, can you figure out how to make it go left using this code? Okay, I'll show you how to do it. If input.is action pressed, just like above, make sure it's not just pressed. And instead of doing UI right this time, do UI left. This is the left arrow key. Close the bracket and add the colon. And this time you want to decrease velocity x by 1. Okay, now if you run the scene, we should be able to move both left and right now. But we still can move up and down. So now if input.is action pressed UI up, then I want to increase velocity.y by 1. Why increase though? Shouldn't you be, sorry, I want to decrease it. Shouldn't you be increasing it? In computer graphics, the y coordinate actually increases going up, as the origin is in the top left instead of the bottom left. So it's not like math where y increases going up and decreases going down. But you'll get used to it soon, don't worry. So finally, if I click the down arrow key, UI underscore down, I want to increase the velocities y by 1. Now if you click F6 to run the game again, everything seems to be working now. I can move up, I can move down, I can move left, I can move right. It all works. Except there's a little bug here. If I move right and then move up at the same time, if I move diagonally, it actually moves faster. Now, to fix this, in this line over here where I multiply velocity by speed, I'm actually going to set velocity to velocity dot normalized multiplied by speed. I'm normalizing velocity before I multiply it by speed. Now, if you don't know about vector normalization, remember, check the vector math link in the description below. So now I'm multiplying the normalized vector by the speed. If I click F6, then I can move left, I can move right, I can move up, I can move down. But now I'm going the same speed if I move diagonally. There, it all works. Our player is working now. So in the next video, what we're going to be doing is adding in a coin or several coins that the player can collect. Okay, thank you for watching, and see you then. Remember to like and subscribe if you like the video. Bye.